Hi everyone, I'm Marcus Voss from AXO, and today I'm going to tell you what software architecture is and how to pragmatically sort through the many architecture styles, reference architectures, and architecture patterns. We remember, in the video on architecture, I explained what architecture in general basically is, what architectural goals are all about, what architectural styles, reference architectures and architecture patterns are, and what role they play, and what task areas can be distinguished. Now let's transfer all of this to the more specific topic of software solutions or software systems. Here, the 4 task areas are exactly the same as for architecture in general. However, the requirements are of course completely different. For our software example, let's assume that a solution with several features from 3 functional areas X, Y, and Z is to be developed. This is an example of functional requirements. The architectural goal or non-functional requirement here is that this solution should be maintainable in the long term, that is, that both functional and technical changes or extensions should be possible efficiently. This requirement of maintainability is one of the typical ILITs, more precisely qualities or quality requirements. Even more precisely, maintainability is a so-called evolution quality, which is anchored in the static structure of a system, in contrast to execution qualities such as performance, which concern the behavior of the system at runtime. We go into this in more detail in the video on architecture requirements. With this architectural goal in mind, we now look at known and proven architectural styles, reference architectures, or architecture patterns. With respect to the architecture goal of maintainability, we, for example, decide to choose the architectural style of a microservice architecture, in which the individual components in the form of so-called microservices can be replaced relatively easily by modified or even completely new ones. The particularly loose coupling associated with this style even supports this. Furthermore, with a view to maintainability on a smaller scale, we opt, for example, for a clean architecture with clear separation of business and technical aspects, in the form of the architecture pattern known as hexagonal architecture, and we determine that we want to design all microservices internally in this way. Of course, in the spirit of the example, this is simplified, but in principle, we are done with defining the general architecture so far. On this basis, we move on to the specific design. Since we use, for example, a design method oriented to the domain-oriented structures of the respective domain or the respective business, such as domain-driven design, the 3 domain-oriented areas X, Y, and Z may then also be found in the design in the form of domain-oriented components or microservices X, Y, and Z, all internally hexagonally structured. This is then the finished template for the actual construction, because the actual software, that is the code, is now written in exactly the same way, structured according to this in both the large and the small. So far, so good. So, you see, the analogy with the general definition of architecture works in principle on all levels. As described, an essential part is the work with architectures or reference architectures, with architectural styles and architecture patterns. There are many of these, each of which is more or less suitable for different architectural goals. In order to be able to deal with this systematically, we need the knowledge about it well prepared and ordered, with regard to the many different aspects, views, and levels of abstraction. Therefore, we pragmatically sort the world here into 4 essential categories. Within the domain of architecture and design, which we deal with here and in the following videos. First of all, let's define the category of design methods. This has nothing to do with architectural styles or patterns. Rather, it is about the methods or the process and the respective approach. Object-oriented design, for example, follows the approach of designing a solution on the basis of object-oriented concepts and ideas. We have already talked about OUD in the video on software engineering, as well as about MDD, which is based on OUD, and additionally brings the model aspect even more into focus. Of particular interest for many of our design tasks in practice is the so-called domain-driven design. As the name suggests, the focus here is on the idea of orientation to the specific domains or businesses and their structures. We will go into more detail on DDD in a separate video, and so now to the actual architecture. Here we distinguish between 2 categories. The first is what we will now call architectural styles. Here we classify everything that has the character of an overarching basic structure and defines how a software system is structured as a whole or in the large. We do not look deeper into the details of the individual component types, which is why it is more of an external view. And it is also a rather strategic design view. Here are some examples of architectural styles. The style client-server says that the system is built from components that are either clients or servers, with server components providing services to client components that use them. In the monolithic style, the whole system is a single large whole in terms of deployment. The monolith, as a specialization of it, is internally at least neatly organized into domain-oriented components. Service-oriented architecture has loosely coupled components that align with the services of the business. The microservice style specializes this in that the components, then called microservices, tend to be even smaller and also even more loosely coupled, as well as also independently deployable, as well as potentially technologically heterogeneous, etc. We will go into more detail about some of these architectural styles and what goals can be pursued with them in separate videos. In the category of architecture patterns, we classify everything that has the character of a deeper design structure and helps to implement a solution for a specific and local problem within an architecture. So, unlike architectural styles, this is more about the detail view, the interior view, or even the more tactical design view. Thus defined, we use the two generally already defined terms architectural style and architectural pattern here, with more concrete semantics in the context of software systems. Examples for architecture patterns are, for example, the well-known patterns Model View Controller, Model View View Model, or Presentation Abstraction Control. Clients of a client-server architecture in the sense of a graphical user interface can be structured internally according to these patterns. Then, all patterns that have to do with the cleanest possible separation of the various concerns within our software. This starts with the classic layered architecture, in which the user interface, upper layer, is separated from the application core or business logic, middle layer, and this in turn from data access and database, lower layer. Later this was generalized with hexagonal architecture, which is also known as ports and adapters architecture, or even more generally with onion architecture, whereby in the middle here too is the application core in the sense of pure business logic, for example in the form of the associated entities and use cases, and around this core the various technical services are arranged loosely coupled via interfaces or adapter mechanisms. Clean architecture, as defined by Robert Martin, builds on these principles and emphasizes in particular the aspect of the reversal of dependency, namely from the outer rings or shells of the onion to the inner ones. Further into the category of architectural patterns, we sort what in domain-driven design is called tactical design patterns, for example entity, value object, aggregate, domain event, service, etc. And command and query responsibility, segregation, CQRS, according to which query, that is read operations, and command, that is write operations, are architecturally separated from each other, also falls into this category, and many other patterns more. We also deal with some of these architectural patterns in separate videos. And a more extensive overview of both architectural styles and architecture patterns is also given in a separate video of the same name. The fourth category then contains the patterns that lie one level deeper, which we no longer assign to the architecture and design domain, but which concern the fine design of the software within the framework of the implementation domain. Here we find then the classical design patterns, or software design patterns. Most prominently, here probably the patterns from the catalogue of the Gang of Four, which can be divided for their part into three categories, namely structural patterns such as composite, facade, proxy, adapter, etc., behavioral patterns such as strategy, iterator, observer, etc., as well as generation patterns such as factory, builder, singleton, etc. There is also a separate video on best practices in this area. Of course, the division into exactly these four categories is not always clear-cut. For example, tactical design patterns and general software design patterns. Nevertheless, from a pragmatic point of view, this order is sufficient, and we can now take a closer look at the individual concepts sorted there in order to understand what is hidden behind the term software architecture. But before that, let's take a step back and look at what the tasks and responsibilities of an architect actually are in the next video. Until then,